Good morning, guys. Today we're going to start talking about angles and arcs and circles, and I will apologize about the pictures being a bit blurry. I'm probably just going to go ahead and redraw that for you. Don't judge my drawings of circles. So my hover cam, the thing that I'm making this with, will not zoom for some reason, so I'm having a hard time zooming in and out, so that's why it's a little small also. Alright, so if you have a circle, okay, and we're just starting with the vocabulary at the top, an angle that has the corner of it right here in the center, that's called a central angle. So it's kind of easy to remember because the vertex is in the center, so it's called the central angle, this one here. That's what's in the picture. Okay, so they're pointing to that. This is a central angle. And the way I remember it is that vertex of the angle is in the center. Alright? Then it says if the measure of the central angle, like in this case they're calling it APB because there was an A here, a PB, a P here, and a B here, is less than 180, then A and B and the points of circle P in the interior form a minor arc. So what they're saying is, as long as it's smaller than half the circle, this piece right here is a minor arc. Now all an arc is a piece of a circle, so it's a curve. But if it's less than half the circle, it's called a minor arc. Okay? Now the neat part is these two have the same measurement. So say this was a 60-degree angle, then this would be a 60-degree arc. Okay? They're the same. That's a neat thing. And the minor arc and the major arc, the difference is the major arc is whatever the whole thing is minus the minor. So majors are always going to be more than 180. Okay? So the major arc would be out here. Okay? So if you happen to have a diameter, so I'm going to add to this picture real quick. So it's a good thing we're drawing it. So say you had A and B, we'll call this C, and we'll have a point D over here. Okay, so we got all these points. AB is a minor arc. Okay, ABC is a semicircle because this is a diameter, or you could say ADC. Okay, so a semicircle. So you could say this would be arc ABC or a DC. They're the semicircles because they start at A and end at C, which is a diameter. Okay. Now the major arc has to be more than that. So the way I've drawn my picture, I have more than one major arc, but I have a major arc A, B, D, or you could call that same one A, C, D. So how you name a minor arc is just by the two endpoints because it's the shortest distance. But if you wanted everything but this, I would have to use another letter to say which way I'm going. So ADB or ACB would be this whole piece right here. So arcs usually have 3 letters so that you know which direction you're going. If they only have 2 letters, then they're a minor arc and you just go the quickest way there. Okay? So that's basically the new vocabulary up here. Alright, so you know a circle is 360, so that's kind of why if it's less than 180, it's a minor arc. If it's 180, it's a semicircle, half the circle. And then if it's more than 180, it's a major arc. Alright, and then the other picture has some new vocabulary word too. So it says an inscribed angle is an angle with the vertex on, not in, on the circle. Okay, so notice the vertex of this one is right here. It's not floating on the inside, it's not floating on the outside, it's literally on the edge of the circle. Okay, the arc that lies on the interior of that, so in this case right here, this arc is called an intercepted arc. Okay, intercepted, like in football. Okay, So the arc out here is not intercepted because it's not in between the two rays that make up the angle. Okay, so that's what this picture is. This says inscribed angle, this says intercepted arc. I do apologize again for it being so small. I can't even zoom in on here. That's new though. Alright, so when you look at these first couple examples, they're all about this piece of information, that central angles, right, are equal to their arc, okay, and they're in the center. So in this case, this symbol you'll see sometimes because some typeface will not let you do an arc. This is what they're saying. That's still saying arc. Because if they were wanting an angle, they would be using the angle symbol like we did right here. Okay. So in this case, it wants MN. Notice it's only 2 letters, so that's the shortest distance from here to here. Well, if this angle is 45 and this angle is 85, that means this arc is 45 and this arc is 85. So we just add those together to get MN. So 45 plus 85 is 130 degrees. So that's the answer for that one. All right. This next one here, the same kind of thing is happening, but they still want MN. So MN is here. Okay. So what you know is that over here is 160. Okay. They told you that. That's from M to P. This central angle here is 35, which means this piece is 35. Okay, so you know a whole circle is 180. So what you do, I'm sorry, 360. I apologize. So you add the 160 for this piece. You add the 35 for this piece. That gives you 195. And then you subtract that from 360. So MN is 165 degrees. Okay. Now these next two, we're not looking for MN, we're looking for X. And I'm sorry I forgot to put find X. This is just on our notes, but X is here. Okay, that means it's using this angle. Okay, so they didn't tell you that one, but if this is a diameter, and I know it is because it goes through the center, that means it's 180. Well, if this one's 140, that means this one has to be 40 in order to make 180. So if this is 40, so is this. So 6x minus 8 equals 40. So then you just do your little algebra. We have a minus 8, so we add 8. Remember I said that we're going to be doing a lot of algebra this unit, so hopefully we have those skills or are willing to brush up on them. We divide by our 6. Okay, so x is 8. Okay. On this one, it's similar, except for they don't tell you any angles. They do tell you that these two angles are equal. But if this is a diameter, then you know that it's 180 degrees. If 180 is broken into 2 equal, then that means they're both 90. They have to be. Because the only thing that can be equal and add up to 180 is 90. So that means x plus 93 is equal to 90. Because if this is 90, then this is 90. So then we just minus our 93. So we can do it in our head, in our calculator. 90 minus 93 is negative 3. Now, I know I told you that you can't have negatives. You can't. Not for side lengths, not for arcs, but x is not either of those things. If I plug x back in, I get a positive number. So your variable can be a negative as long as what it's representing is a positive. Okay? So that's our first rule, basically, is that the central angle and its arc are equal to each other. Okay? That's not even really a theorem, it's just something that's true. It's how it's defined. So look at the next slide, or the next part of the next theorem, sorry. That was actually 2 slides, the definitions. This next theorem is about the inscribed angle that we were just learning about. It says, if an angle is inscribed in a circle, then its measure is half the measure of its intercepted arc. Okay? And so I know the pictures are a little blurry, I do apologize. But if you look in this picture, here's an intercepted arc. Okay? That means it's half, here's a inscribed angle, it's half of its intercepted arc. Okay? Now remember, its intercepted arc is half, or is equal to its central angle. So by default, that means that also an inscribed angle is half of the central angle that they share the same arc with. This isn't really a theorem, it's just if one thing means one, we learned the first rule that this and this are equal. So if this is half of this, then it's also half of this. Okay? So if you look at this one, here's our intercepted arc. It's 194. If this is half of that, you just divide by 2. So 194 divided by 2 is 97. That means this is 97 degrees. Okay? Here, they want arc BC, which is here and here. So you got to kind of think backwards here. The angle is half of the arc. If the angle is 90, what's 90 half of? Well, it's half of 180. Okay? Same thing kind of goes here. This 70 is half of this. So if this is 70, then this must be 140. That's how we're able to solve this. 141x minus 1 equals 140. We add our 1. So 141x equals 141. You can divide by your 141 in front of the x. So x is 1. Okay. Sorry, that got off the screen. Okay. So that's our first theorem that we're learning, is that an inscribed angle is half of its intercepted arc. Okay. So basically, if the vertex is on the edge of the circle, then whatever arc it intercepts, it's half of. Okay. This next theorem is really a corollary to this theorem, meaning it exists because of this one. So if you look at the next slide, it says if two inscribed angles of a circle intercept the same arc, then the angles are congruent. So in this picture, this angle, C, it intercepts this arc. But angle D also intercepts this arc. So if they're both half of this, then they have to be the same thing, because you can only half this and get one answer. So that's what this says. Angle C is congruent to angle D. And really they didn't say it, but the same thing applies over here. This arc, CD, means that this one, A, and this one, B, they both touch CD. So angle A must be congruent to angle B. They didn't put that in the picture, but it's true also. Alright, so in this picture, if you look, this angle that we have marked with this expression, you follow it, it's intercepting this arc. Okay? Well, this angle is also intercepting this arc, so they're equal. Sorry about the barking dogs. That's the downside to teaching from home, is they are here too. Okay. If the angles are equal, then their expressions are equal. So then we just do the algebra to solve for x. So we got 7 equals 3x minus 11. So then we have to add our 11. So we've got 18 equals 3x. We divide by our 3. So x is 6. Okay. This is basically anytime they share an arc. Just so y'all know, this is, he's upside down. This is what my lap is the whole time I'm trying to teach. He won't let me be alone. He's spoiled. Alright, I'm going to keep working the notes, but I'm going to put it in a separate video, so keep watching for the next one, because I don't want them to be too long, so you can break them into pieces.